All right, so this is our last office hours for phase 4. And to start, we'll go through, I think there's just this one question on like word embeddings and like similarity. And then if there are no other questions on this project, we can start talking about the capstone. So let's start with this question here. Just can you walk through the process for using word embeddings to see the most similar words for a specific word? Not clear on the process to use an existing library of embedded words and filter my corpus to then use that to see most similar words. Okay, and then where does this fit into the overall picture of NLP and neural networks? This doesn't actually require building a neural network, as I recall. All right. So I think the notebook that would be most helpful, and oh my gosh, I hope I don't have to like reload all of these vectors. I might have to. So let's give that a minute. But basically, if you have a bunch of word embeddings to find like the most similar words for a specific word, I'm guessing you mean the most similar words for a specific word that exists in your corpus, I'm guessing. So if that's the case, you can actually run a nearest neighbors model to figure that out. So if you have let me look for nearest neighbors. Oh, I want scikit-learn. So within nearest neighbors, not this one, but let's see here. So with your nearest neighbors, you can actually fit in your entire thing of embeddings. And then you can run your k neighbors. So for example, you fit your entire data frame of like words or documents. And then what you can do is do k neighbors. So you can see here, let me zoom in a little bit. So after you fit it to your nearest neighbors, doing k neighbors, and you can see here, you're finding the k neighbors that are closest to this array, and you're finding the 2 nearest neighbors. You can return the distance if you want or not, but you can pretty much do that and basically use it as like a find most similar. If you want to find like the 5 most similar documents or words, this is what you can use, and you can use the embeddings to do that. Anything to clarify or questions from this?
Isn't this something you could do with the, what was it, glove, and what was the other one?
Okay, so this is done. So this is vector lookup, and this is like with the glove. This is with the glove pre-trained vectors. So that means I'm downloading this, and this is literally downloading like the length 100 vectors for all of the words in here. So I wonder if this will actually show me. I wonder if I can find the length of this. I'm not sure if this works or not. Okay, I guess not. But basically from here, I'm looking up, the vector for caffeine. My notebook's a little bit laggy. And you can basically look up the vector for any word that exists in this corpus. So for example, there's going to be certain words that don't. I think, yeah, I is not in there as an example. So if you're doing the word similarity, this will search through the existing words in the glove pre-trained vectors that I downloaded. So I mean, you can definitely do like find most similar and then filter this for like the words that exist. That's something that you can do. I want to take a look at the question again. My computer's.
I thought there was some way that you could take that list and then filter it with your unique corpus and then look up the word. You know what I mean?
Yeah.
Map
Yeah.
those vectors onto your unique words.
Yeah, absolutely. Yeah, so for example, let's just go with like my unique words. So as an example, let's just say that I have like a corpus of like coffee and like tea, I don't know, water, wine, just as an example. You could get the word vectors. Again, it will depend on like what you're pre-training it on. So you can do like, let's do a list comprehension just for that. So we can just create a list of word vectors, and it can be word vectors W for W in words. And you can see that this gives me 4 arrays. And then with this, you can just run similarity between each other. That's one way to do it. Is that what you were talking about?
I think so. Yeah.
Okay. Yeah.
If you have any good references to suggest, that would be helpful too.
Okay. Yeah, for sure. I'll look up. It would be helpful to know like the exact context in which you were planning to use this, just so I can find something that works in context. Because like all of these things, I feel like it does depend on what exactly it is you're trying to do, because there are so many different functionalities within word vectors. So it would be helpful if you want to like Slack over to me what you're using these similarities for.
Okay.
I can look up.
Great.
There's probably something on like Towards Data Science, honestly, that walks through this. But yeah, and there's another part to the question. Where does this fit into the overall picture of NLP and neural networks? Yeah, you're right. This word embeddings that are already pre-trained don't require building a neural network. That's absolutely right. How, and I guess now that we have like a little bit of an idea of how neural networks work, how these are obtained, these are actually obtained through a neural network. So this vector, you can imagine that this resulting vector per word is the result of feeding the word through some trained neural network with a bunch of weights. And this is basically the last layer with like 100 vector output, if that makes sense. So this is sort of the result of a neural network that has been trained on like a bunch of text. So yes, you don't need to build a neural network to use word vectors, but word vectors are a result of neural networks. Does that help answer the question?
Yeah, it does. Thank you.
You're welcome. In the case of, I believe, I want to say that in the appendix, they have you create your own word vectors, like you can train your own word vectors on your own set of texts. Everything's already built in the back end, so you're not actually you're not actually building out like a Keras neural network, for example. But what's being done is very similar to training a neural network, just in the back end. And I believe they use like GenSim to do that, if I'm not wrong. I just saw another question come in. Extracting feature importances from my random forest model gives me an array of floats. How do I translate that into actual words? Yeah, that is a great question. Let me pull up this notebook and we'll see whether I can get it here. I believe I have an example here. All right, looks like I tried to do this before. So this was the satire versus not satire thing. So let me just figure out where my model object is. So this is my data. All right. So yes, in getting the feature importances, I hope this is still run. All right, yeah, feature importances exactly right is going to be a bunch of floats. Now you would have to match these floats come in the same order as your input dictionary, input data frame, sorry. So, oops, I copied that and I didn't paste it. Here. So you basically take your X data, whatever you fit your model on. This is what it is. Oh, sparse matrix. Is it too dense? Forget. Let's figure out which one it is. I always forget what the actual one is. Sorry, bear with me for a little bit. There you go. Too dense without the underscore is what it is. So this is my array, and I have my pd.data frame. Oh, I know it. I also have to get the column name. So basically wherever my TF-IDF was created, you can actually extract your feature names. So we can get this from here, I believe. Go. So we have to get it from the vectorizer.get feature names. Let me take a look and see where this comes in. All right, this notebook, I ran it and I also reorganized it while I was going through it. So I'm gonna take a while to find everything. But basically what I'm trying to do now, which is the process that you're gonna take, is you are going to look for there it is, tfidf.get feature names. You can extract all of the column names from your vectorizer. Get feature names, there we go. And these are all your feature names. All you have to do now is do a zip of, let's do it with the feature importances and the feature names. Hopefully this is the same model. There's a bunch of different models in this notebook, I remember. Awesome. So basically this is what you have. You can also sort it. Oops, and then I want to do, I think, reverse equals true. Is that right? There we go. So based on whatever this model or whatever this problem was, you can get the most important words just by zipping together the feature importances and your feature names. And the feature names you get from your vectorizer object. Cool. So let me put that down there. You get your actual words from the vectorizer using the method .get feature names and zip that with your array of floats. There you go. Let me just make sure it is get feature names. Yeah, there we go. Cool. Let me do a quick last check for questions. If anyone has any questions at this point, feel free to let me know right now. But I think we're good. Yeah. Any final questions for the phase 4 project? Awesome. Oh, yes.
If we have time, I don't know how much time we have, but do you know how to use the predict function for LightFM?
I do. I have used it before.
To get the predicted ratings?
Yeah, let's see. So I assume that it works the same way, honestly.
I'm just having trouble with what you plug in.
Okay, let's see. So it looks like it takes like an array of user IDs, an array of item IDs, and it also takes in, I guess, I know in your case that you don't have user features, and there are item features here. So it does look like you have to give it your item features.
Like the matrix that was created for the item features?
That's right. It does say optional, but I do think if you want to consider the item features, you do have to give it, pass it into your predict function as well.
Okay.
Yeah. So let me just throw this in there. Oops. Oh, cool. But let me just throw that into the recommendations section, just for future reference. Making predictions. And this requires you to feed in arrays of user item IDs as well as your content matrices. All right. Anything else regarding phase 4? All right, I know you all are starting to get anxious about capstones. I mean, rightfully so. So let's talk about it. Here, I'm going to definitely keep adding to this as we go through material, but I don't want to overwhelm you all right now. Here you can see I've put a bunch of example recommendations all across like different, I've tried to group them, but I don't think they're really like into groups because each of these projects do have different things from different topics. So feel free to take a gander. There are a bunch of text ones here. I put a bunch of time series ones here. These I will say are more neural network ones, and these are all like some sort of recommendation system. If you have an idea that like you want to see example projects for, let me know and I can see if I can remember any projects that are similar to what you're thinking of if you want to see an example. But I think that this is a good like bank to just peruse and for your inspiration. Yeah, so feel free to take some time to look at what these are. You'll see that there's also like differing, you would say like maybe like differing like amount of project there is. Like some people's projects are really like, you know, literally just like a phase project with a little bit more. Some people's projects, they're doing completely new things. Some people created like intense neural networks. So this goes to show that there is a range and it really does depend on each student. So get ready to, you know, as you're pitching your capstones to me, and that is something that you're going to do within the first week and a half. As you're pitching your capstones to me, and it really just has to be a one-on-one. You can also pitch it during our project review. As you're pitching your capstones to me, do consider like, all right, if I'm going to do like a smaller capstone overall, what is my reasoning for that? And also like, where are you going to build on? So example projects all here. If you're looking for something more specific, just let me know and I can send it over to you or add it to the list. So there's that. Now, just to let you know, we will be having office hours throughout the whole capstone phase, same time as our study groups as well, just all 4 weeks will be office hours. And then the office hours will go through to like the end of week 4. And then after the 4 weeks, you have the regular like 2 weeks to pass the review with me. So I've already added to the calendar stuff for week 1. And I think this will be stuff that's going to be more relevant for, you know, as you're collecting your data for your project before you even start modeling or anything like that. So Monday and Tuesday are going to be your phase 4 project presentations. I will put out like an order of presentations. If any of you have any preference to be on either day, let me know by today, just so I can do that. I'll also put in the Slack later for people who aren't here. On Tuesday, I'll go into more detail about the capstone itself. If there's anything I don't go through today, I guess. On Wednesday, we'll be going through a review of APIs and web scraping. Thursday, I'll talk about how do you build SQL databases. I'll be talking through a couple ways to do that locally. I'll also send out resources for potentially doing it on AWS, just in case you all want to build AWS SQL databases. And then Friday of next week, we'll talk about Jupyter Dash. And Jupyter Dash is basically, Dash is the dashboarding software that is built with Plotly. And Jupyter Dash is the sub-library of that allows you to do it within your Jupyter notebook. So you don't have to worry about like creating like a new thing yet. I will say once you're done with your Jupyter Dash, it's very, very easy to port over to like an actual like web page. So we'll start with that. Week 2, so next week I'll also be taking like any requests for specific topics that you want to deep dive on. This will also partially be guided by what your projects are. So if I see like a vast majority of you doing like clustering as part of your project, I'll take some time to talk a little bit more about the applications of clustering, just as an example. Also, you'll see here preparing MVP presentations. So MVP stands for minimum viable product. While you're pitching your project to me, this is something I'll ask about. And this is literally like, all right, if for some reason you only have 1 week to complete this project, what are your deliverables going to be? But for our case, MVP presentations are really just more going to be like a very, very informal presentation of where you're at this moment. One, it keeps you all accountable. It's very, very easy to like lose track of, I don't know, lose discipline over this phase just because you have a lot of free reign. So we're going to have like presentations throughout week 3 where you will just share where you're at. And I'll go into more detail about that during week 2. So don't worry about that for now, but just know you don't have to prepare a slideshow or anything. You're just gonna like tell us all about your capstone project, really. Also in week 3, I'll start talking about how to create a front end. So this will be different kinds of front ends. So I'll talk about dashboards. So if you're doing like a very, very heavy EDA for your project, I'll talk about how you can build a dashboard for it. I'll also walk through the processes of using Flask. Flask is basically something that allows you to host any of your machine learning models. You can also host like a neural network on Flask potentially. And basically it'll be a very, very simple web page. I think I showed you all before one of my examples where you can like just what I did it on my NLP project. I just typed in some words and pressed the button and it ran my model and created predictions. So I'll talk about how to do that on week 3. Finally, in week 4, I'll be taking questions. Also, I'll talk about polishing your GitHub. I've been talking about, your READMEs and like your file architecture per project, but I'll go through some more details on like, your entire GitHub as a whole. How do you make it more of like a presentation piece for employers? So I'll be talking through details about that. And then also just any loose ends that we have to wrap up. Throughout all of these sessions, every single study group, I'll have time for your capstone questions. So here, this doc will be something that I will keep referring back to every day for the next 4 weeks. So any questions that you have or any topics that you want to deep dive in or anything that you feel like, I don't know, if there's something that you think is worthwhile exploring further, feel free to drop that in there. So yeah, that's kind of like what to expect in the next 4 weeks. I think it's kind of cool that like our capstone period kind of like aligns with the month of February. That's just like a random thing that I noticed. But anyways, any questions with anything that I've mentioned so far? All right. So next I'm going to talk about, because I think some of you who are wrapping up your phase 4 projects right now want to start thinking about this, coming up with project ideas. I will say for me personally, this was the hardest part. And I think it's like either or. You either already know exactly what you want to do, and that's awesome. But if you're in like where I was, where I'm like, I have no idea what I want to do. I've learned all of this stuff. I don't know what I want to apply and like what my final product's going to be. I will tell you, I had no idea what my capstone was going to be until like a week before it was due. Don't do what I did. Over the couple of years I've been teaching, other instructors have created project planners. And this I think is really, really helpful for just laying out all of your thoughts. So here's an example. There are 2 different formats. Feel free to use either one. If you want to fill this up to show me, that could work as well. But just keep in mind that not every field is going to be relevant for every project. So definitely you can take it with a grain of salt. You can tweak it if you'd like. But basically you can see, this is just one of the examples. There are 2 of them. Oh, and with these, you just have to make a copy of it so that you can edit it on your own. You just go to File, Make a Copy, and then you'll just have your own version. So you can see like there are very, very straightforward questions here. Like for example, what is the topic of your project? Business or social case? Why does it matter? Why is your project important? I think yesterday during my spiel of business case, it's super important. So that is something that I wouldn't change. What libraries do you plan on using? What are your data sources? Yeah, and one thing to remember, no off-the-shelf data sets. I'll talk about that a little bit more later as well. Domain knowledge, visualizations, your minimum viable project. I'll talk about what an MVP is in a bit as well. And beyond that, other notes. So this is just one of the examples. Again, this is just a guideline. I know not every field is going to be relevant to every project, so remember that. So you don't have to use this. I find that for myself, being able to at least fill up some of these things keeps me organized. So yeah, it's really up to you whether you're gonna use these. The other one is, I think, in a spreadsheet format, more colorful.
Fine.
A little bit more colorful, and yeah, same sort of thing. Like, what is the problem you're trying to solve? What kind of models are you going to use? Tell me about your data. What EDA is important? Is your data representative? Feature selection, data cleaning. Yeah, again, feel free to change this up if needed. So yeah, feel free to use these to plan out your projects. Even if you already have an idea, I think sometimes a good idea to like break your project up into different parts. And so you can think about what you have to prioritize when. So more about like the specific scope of the project. Let me see, in the phase 5 page, you can go through and read that. I am gonna like reiterate some of this next Tuesday anyways. But all in all, at minimum, your project just has to be an equivalent of an end of phase project with something added onto it. And so for most people, a minimum viable product, like if you are really like in, I don't know, if you really don't have the time, if like something's come up, at minimum, you should be able to submit what is equivalent to any of the phase projects, run a bunch of models, be able to make some evaluations and recommendations. So if that's what you can do in that like 4 weeks of time, that's what you got. But yeah, what else I have to talk about? Oh yeah, so MVP, minimum viable product, should be a phase project, and then the capstone element would just be adding something extra to that. And whether that something extra is additional EDA, like a very, very in-depth EDA or a dashboard that you build out, whether that is additional models, maybe you want to combine like, I don't know, PCA clustering, maybe you want like, I don't know, what is something else that we can do? Maybe like word embeddings for an NLP project rather than just TF-IDF. That is fine too. Or creating a front end. That's also another common extension to like a phase project that you can do. In terms of coming up with, oh wait, yeah, before I move on, any thoughts on any of what I just said? Yeah, so as you're coming up with project ideas, feel free to run them by me. If you want to like Slack me your idea, the more details I have, the better, of course. But yeah, if you're having a tough time coming up with project questions, these are some questions that, you know, students, I think it's helpful for students to ask themselves. The first one is what I kind of went off of. Are there any specific models that you'd like to use in your project or specific topics? So I knew straight off the bat I wanted to use SVD in my final project. What data, the hard part was choosing the right data set or finding a data set that actually spoke to me. So if you have like some sort of anchor point, it's easier to go off of there rather than just going in and like trying to feel around for everything. Other things to think about is, are there specific industries that you really want to get into? If there are, like, honestly, look it up on like Towards Data Science, or look it up on like, honestly, even LinkedIn. You can find a lot of people's past projects. If you find people who work in certain industries, you'll find their past projects, and those will likely be projects that are relevant to the industry that you want to get into. Finally, I think this is slightly rarer. If you happen to come across a data set that you're really, really interested in, or an API, you can sort of build your project around that. I would say like with that, usually from a data set, extending from, you know, a data set interest is a lot easier. But I know most people don't already have like, oh, I definitely want to work with like this API, for example. Places to search, honestly, Towards Data Science, which I like a lot, on Medium, has a lot of examples of data science projects. I feel like don't be afraid of doing a project that's very similar to something that you found. It becomes problematic if you find yourself copying code from another person's project. Don't do that. But if you see like a project topic, like for example here, like you see someone did a recipe recommender. It doesn't mean that you can't do a recipe recommender. You can definitely draw inspiration from that and build something similar. But don't let that stop you from building something that you want to build. You shouldn't say like, oh man, someone already did that, so I can't do that. That should not be a deterrent. I will tell you that, like, I know that in college courses, when they have like machine learning courses or any computer science course, everyone does the same project anyways. So as long as, you know, you're doing I feel like the fact that you're doing a data set that isn't taken off a Kaggle or something already gives you a leg up. What was I talking about before? Oh yeah, thinking of project questions. Look up towards data science. I really, really want to emphasize that. Places to look. I like, oh, actually, I already said places to start. So explore towards data science. There, you can basically search within the publication, and a lot of projects will come up. Also, something that I did, I think I told some of you, I actually did a GitHub search because I knew what algorithm or what kind of model I wanted to use. I just searched on GitHub for other people's projects. So search through GitHub. So for example, I looked for like recommendation systems. So literally look up recommendation systems, SVD or something like that. And a lot of things come up. I don't know, at this point, are there any people who is there anyone who's like really nervous about finding something that maybe I can, I don't know, assuage those fears? Cool. Well, I will be taking note of what your final projects are. So as y'all tell me, I'll be just noting down what they are. So I'll know who has told me what their project is. So yeah, just when you find out, let me know. We can talk about it at one-on-ones. We can also talk about it like during the project reviews if there's time. So yeah. Any other questions at this point regarding capstones?
Could you maybe talk through a little bit, because you said we're not just taking a data set from Kaggle, we're obviously creating our own data. So could you talk about different ways like people have gone about that, and what are different ways to extract different data sets? I know there's API and web scraping, but other things.
Absolutely. So yeah, I didn't really want to talk too much about it because it's pretty much here. So yeah, you cannot use an off-the-shelf data set and just like, you know, take it clean, plug into your model. There has to be some component of you synthesizing data or creating a unique data set. I would say that the most common, or I think the most straightforward way to get around this is by using an API. As long as you're using an API, even if it just comes from one source, that fulfills the requirement. If you are using web scraping is usually you end up with like a unique database. So if you web scrape, again, if it comes from the same source, that is fine as well. Another thing that is also possible is if your data set has multiple tables. So there are a couple data sets that exist on Kaggle that are just very, very robust. And so in like the one Kaggle data set, they have multiple tables involved. So with that, I do think that that fulfills the requirement because it does require you to, you know, synthesize separate data together. So that counts as well. It's definitely one of the harder parts there. If you look up, I'm gonna look it up for you. There is actually a list of like data sources. I need to look, I'm not sure where that is right now, but there's like a list of data sources for machine learning projects, which I will look for that list. I remember it's like on a GitHub README. So I will look for that for you. I believe it might've been on one of your project outlines, but I forget. I'll look for it. So that will just be like a bunch of, I know it lists like good APIs, a couple of like, not just Kaggle, but other places that you can source data. So I'll look for that and link it here. But yeah, as you can see here, most of you are going to be doing something related with supervised learning. So it does say must be appropriate for supervised learning models, but again, it really depends on if you want your project to be something else. You can just let me know and we can figure out if that is going to be like a robust enough project. I think that's the main one. Yeah, somewhat complex. You should have a pretty big data set. I mean, I think part of like, I don't know, one of the harder parts is working with just like really large data sets and getting used to like cleaning like tons and tons of inconsistencies. So having a good enough like big data set, again, it doesn't have to be like big data, but I would say like you want to have like thousands of rows at least. So that's something to consider as well. So I know anything off of like the UCI machine learning repository is not going to be big enough. I think most of those are like under 1,000. Unfamiliar, this point, basically anything that you've seen in a lab should not be used, because I know all of the ones in labs are very, very common data sets, like things that are used in like things that are already built into libraries. So you're probably not going to run into that problem if you use like data that you source yourself. But yeah, I think this is a good thing to read through. This is, I believe, the same content that was in the last project. So yeah, just ways to like come up with problems. Oh, I think this is what I was talking about. Oh, awesome. This is the resource I was talking about. It's basically a bunch of like different resources for categorizing like different subcategories. So if you're interested, if you're like just trying to source data, I think this is a really good place to start. Like you can go through, like, I know a lot of you are interested in healthcare, so you can take a look at like all this healthcare stuff. What else is there? Time series, a lot of time series data here. I know that there's another resource that has like more APIs, because I believe that these are mostly like data sets. So I will look for that one specifically too. All right. But yeah, I think, oh, one other thing, if you see like someone's project here that's using a data set that you're interested in, you should not take their data, instead just source the same data yourself. Like write your own code to like API call. I think most of these are, a lot of these are like API or scraped. Like I know that this one I think is scraped. This is scraped. These are scraped. Spotify is an API. I know this one is Spotify as well. So yeah, New York Times is definitely API. So yeah, this is also a good way to look for data sets, I guess. But yeah, with regards to your data set, you just, as long as you're not just taking a single table that has already been built and using that for your project, as long as you're doing something more than that, if you feel like you're in a gray area and you want to clarify, let me know. But as long as you're not just taking a table and running your models on that, you're fine. But yeah, any other questions or like concerns that I can help address right now? I will say most of you are still like finishing up your phase 4 project, so it's completely understandable if you're still focused on that rather than the capstone. So happy to like answer more questions at the start of next week too. Cool. I mean, I would say once you're done with this phase 4 project, I really do recommend that you take like at least a couple of days off of data science before getting into the capstone. Again, I cannot emphasize enough that burnout is very, very real. So if you feel yourself like getting tired or like you just don't have motivation to do any data science, just take like a day off. And I don't know, there's not much that you can do these days anyways, but just try and take a couple of days off if you can. And maybe during those days off, you look at some of these example projects. I don't know. It's really up to you. So yeah, this is, I do not want to like overwhelm you more with like more capstone details. I feel like you guys already pretty much know where to go from here. Hopefully, I don't know, maybe. I mean, I'm gonna go through a lot of this again next week anyways. So yeah. Any final questions to wrap up phase 4 or anything about the capstone either? All right, well, something else as you guys are getting closer to, you know, the career phase, all of these are Flatiron students. So if you find their contact, feel free to link up with them. A lot of them were my past students. So if you want to in your LinkedIn message, just mention that I was in your instructor, you can do that too if you want to connect with them and see what they're doing now. I believe most of them, at least like if you see like when their last commits were, most of if their commits were a really long time ago, most of them already are working. And so if you want to find out more about what they do, you can reach out to them. Feel free to use my name as you reach out to them as well. But yeah, last call for questions. Going once, going twice. All right then.